Do you think a Linux password is a wall? Well, it's not. It's more like a curtain, and today I'm going to show you how to walk right through it in under 60 seconds, without a single tool. Unlike for Windows, this method doesn't even require USB installation media or Linux Live USB. Also, we aren't stopping at this extremely simple bypass. Yes, I'm trying to emphasize, it's extremely easy. If I could bypass Windows login screen in under 60 seconds, this one can be bypassed in 10 seconds or less. And yeah, I will show you something really cool that will make you like Linux more and understand its core logic. Stay to find out what happens when you try to outsmart the kernel itself. We're going to kill the system life just by typing one word. If you want to know how the elite actually control a machine, don't just click away. Also, I'll reveal the one thing, LUKS or Linux Unified Key Setup Encryption, that makes this entire attack useless. And why is LUKS much better than BitLocker? Now let's start with bypassing the password. To do this, we don't even need to boot into the OS at all. We intercept it at the group boot menu. Before the OS starts booting, hit E on your keyboard, and you'll get some weird looking code lines on the screen. It looks like gibberish to the untrained eye, but for us, this is a map to the kingdom. Look at this line. This is where the kernel instructions live. Most people just let it boot, but we're telling it what to do. Let's add the rw space init is equal to /bin/bash at the end of this line. By doing this, I'm telling the Linux kernel ignore the login, ignore the security, and give me a shell directly from the init process. Hit F10 on your keyboard now to boot, and there you go. Right now, I'm the highest authority on this hardware. Let me quickly explain to you what we just did. So we added RW, which stands for read and write. This automatically mounts the partition so we can access all files, edit or delete them. Init is equal to bin bash, sets the init to behave as a terminal, and the bin bash is the terminal itself. Since init is the kernel or system by itself, we don't need sudo or any password. We are the source of power here. Now the cage is open. I can change any user password, delete any user, or steal every file on this drive. Type passwd followed by username. Then type new password and repeat it. Hit enter and you're done. It's hilarious how easy this is. A 6-year-old kid would do this blind in the middle of the night. I guarantee you that. But here's where the script kiddies get confused. They get their root shell and then they try to leave. They type exit. But you need to understand the hierarchy of power here. The init process or systemd in newer OS versions is the father of all processes. If init stops, the entire universe of this OS ceases to exist. So, watch this. Do you see that? The kernel just panicked, and this will happen if I try to run sddm from here. It seems like it's gonna sign me in, but 3 seconds later, look at it. It's frozen in kernel panic state. But why does this happen? Because I tried to exit the one process that is legally required to stay alive. The system doesn't know how to handle an exit from the root of its own soul. And I just showed you the difference between knowing a trick and knowing the architecture. Now you might be thinking, Alex, is Linux security a joke? No, it's only a joke if you didn't set it up right. This attack only works because I have plain text access to the drive. If this machine was using LUKS, my init check would hit a brick wall. With LUKS, the data is scrambled into garbage without the decryption key. Even if I hijack the boot process, I can't mount the drive because I don't have the master key. If you aren't using LUKS in your Linux partitions, you don't have a secure PC. You have a public library. And now, why do I find LUKS more secure by default than BitLocker? Because of the encryption type. While BitLocker often defaults to 128-bit, LUKS is built for AES 256. AES 256 has extremely high entropy and it offers 2 to the power of 256 combinations, which is equal to this number. Yeah, I'm not planning to read it, but security is all about layers. If you lose physical access, you lose the bootloader. If you lose the bootloader, you lose the kernel. Unless you have encryption. If this deep dive showed you something new about how Linux actually works, hit the like button. It tells the algorithm that high-level security content matters. If you're a small channel or a student trying to master this, subscribe to join the community. I'm already planning another video, so stay tuned for it. You never know what it could drop next. Stay curious, stay dominant, and I'll see you in the next one.